Okay, this video is going to talk about binary numbers, and so this is just going to give you a rough introduction to binary numbers. We'll talk about binary numbers a little bit more in chapter 1, but right now we're just going to get the idea of how binary numbers work in the computer. So we are looking at our notes here. And so the first one, binary code or binary numbers, their format is that they use only ones and zeros. They only use ones and zeros. So what you need to put in here is just ones and zeros. And then there's examples. This is binary code or binary numbers because all it has is ones and zeros put together. So as we look at this picture, we get a general idea of how this works. Now, I'm not going to get real detailed about this, and we're only going to be looking at the basic idea because the let's see, where's my eraser? Okay, there we go. So the idea is that it can get really detailed and complicated, and I don't understand the entire process, and it's not important at this point that we do, but just that we get a rough idea of what happens. And so this picture demonstrates that if you were to type on the keyboard here or use your mouse or download pictures from a video camera or something, or download let's say a video from the internet or something, what happens is that information or those programs, those files are all stored as binary numbers. The binary numbers, all these zeros and ones then, are what the microprocessor can read and understand. And then it produces, because it can read and understand it, it produces the printer, it sends something to the printer or it displays something on the screen. So these zeros and ones are actually instructions to the computer on what to do, and these instructions, these zeros and ones, this binary code is what stores the things that are input into the computer. And so if we go down here and start to look at this, what you'll see then is computers use binary binary to store files. They store Word documents, pictures, videos, etc. Everything that's stored on your computer is really binary numbers. It's binary code. That's how it's stored on there. Circuits. Circuits in a computer's processor are made up of billions of transistors. Okay, so billions of transistors, which are actually tiny switches that are activated by electronic signals that they receive. Okay, so you have transistors, which are really switches. They're activated by the electronic signals or pulses that they receive. So somehow inside your computer, these transistors, which are activated by electronic signals, by the flow of electricity going through there, it is actually going to be related to the binary numbers. So the digits 1 and 0 actually reflect the on-off state of a transistor. So either a transistor is on or it's off. Just like if you were to flick the switch on, the light switch on for a room, the light is either on or you flick it again and its light's off. There's no middle stage there. It's just either on or off. The 1 reflects the on position and the 0 reflects the off position. So when you're looking at these ones and zeros, what that really is, what's really happening is this is reflecting, for instance this one, this is reflecting that a transistor that's on, then off, off, then on, off, on. And so that somehow the computer microprocessor understands those electronic signals, this on-off pattern between the different switches and so forth, that it is able, then that's what causes it to produce the output that it does. How that happens, I have no idea. All I know is binary code is what's used to communicate to the microprocessor that causes the microprocessor to produce what it does. So as we look a little bit further here, we see that computer programs are really just sets of instructions. Okay? Oops. They're really sets of instructions. And so that are written using specific programming languages like Java, C++, Python, and there's many more. But we're going to be using Java to write computer programs. So you're going to write a computer program using Java. Now, these instructions are called source code. Okay, source code is what these instructions are called. And the source code that you're writing in Java actually looks like what's in this picture. For instance, it says public static void main, etc. You're going to get used to this line of code because this line actually tells the computer to start the program. And so you'll see that Java, even though we say it's a language, it uses a lot of words that are just like the English words that we're used to using, like public and static and void. It's just that we're using them in ways that at first are not going to make sense to you, but then after a while you see how they work and how they relate and how they cause the computer to do what it does. We are learning how to write source code. That's what you're going to be writing using Java. Okay, that's what we're going to be doing. Now, here's what happens. This source code, the computer cannot read this stuff. So the source code, or the instructions of the computer program that are written by the program, that source code is converted by a translator into binary code. So it goes through some processes until it becomes binary code that can be read by the computer's microprocessor. And so that's the key issue, is that the source code is converted to binary code because the computer cannot read this. The computer's microprocessor then understands the binary code and follows its instructions. So it understands the binary code, follows the instructions resulting in output to a printer or a monitor. Alright, and so that's basically how it works. So the key thing that we need to remember at the top of page 2 is we need to remember that that files and programs that are saved or installed on our computers are stored in the form of binary code. Okay, that's the important issue here. So when you see those icons on your desktop or in folders, or you see folders, all that, it really is stored. The way it can actually be stored there is because it's made up of binary code on the hard drive. The binary example, here's an example. The letter A, for instance, is stored as the following binary number. So 01000001. Okay, in a binary code that you don't necessarily have spaces like this. We do it just to separate and make it easier to read, like you would maybe a credit card account number, or your phone number is grouped into 3 different groups. That's what we're doing here. but in all actuality it's all stuck together. So you have these numbers make up the letter A, and B is the something else, and etc. Now as we go on here, then here's some binary terms to look at. A bit is one digit or character. I don't know why this keeps changing on me. So it's one digit or character. So here is a bit. Here's another bit. Here's another bit. So these are each, this is one binary character each. This whole thing is a byte, and you'll notice it has 8 digits to it. So it's got 8 bits. This is the basic unit of storage. So it's just like in the metric system. You have the meter is the basic unit of length, and so everything revolves around that. And so you have things like a centimeter, which is 1/100th of a meter. You have a millimeter, which is 1/1000th of a meter. You have a kilometers, that means 1,000 meters. So you can see everything revolves around this one basic unit, meter. Well, that's what happens with byte. It's the basic unit of storage in a computer. And so you have a kilobyte. Okay, that's 1,000 bytes. Okay, so 1,000. So it takes 1,000 bytes to make a kilobyte. And if you were to go, well, how many characters is that? It's really 1,000 bytes. So, and which is really going to be 8 bits for each byte. So it's going to be 8,000 bits. 8,000 of these characters. 1, 2, 3. It's going to be 8,000 of those. And so you can see, as for instance, as you type on a document, the more things that you type, the letter A, for instance, is a byte. A B is a byte. There's symbols all that are bytes. As you keep typing, it's storing more and more. And so because our computers are finite, they can only hold so much. You can see why that happens. So a megabyte, for instance, is 1,000 kilobytes. So basically a Word document, well, I'll tell you about that later. And then you have a gigabyte, which is 1,000 megabytes. So you can see it's kind of an exponential growth if you understand math in this way. But there's 1,000 bytes here, and then this is 1,000 kilobytes, which exponentially increases the number of bytes that you're dealing with, 1,000 of these megabytes. And then you have a terabyte, which is the largest one that we're looking at, is 1,000 gigabytes. Okay, so basically in our computers, then when we're storing these files, then basically a basic Word document without pictures is like you could do 10 to 200 kilobytes. Okay, so I mean that's rough. I mean it could be more, but just most of your documents are probably going to be around 22, 23 kilobytes things that you turn in to your teachers, unless you have pictures and stuff in there, because picture files, they can go a small picture is less than 1,000 kilobytes, but remember 1,000 kilobytes is a megabyte, and so a lot of pictures are 1 megabyte long, that big. And I've gotten pictures from a soccer parent some of her pictures are like 7 megabytes. And so that's a large picture. It's large in size, and also the resolution would make it would make it require more to store it, so it's going to increase its size. And then you have video files, which are going to be hundreds of megabytes and get into gigabytes. So it's going to be a lot of megabytes to gigabytes. Okay, so you can get into very large videos. So you can see how the more, as you go to use different types of files, they're going to change in how much storage they require. And so that's basically binary code.